Here is the example, the Laplace random variable and its PDF. And we give you the variance of x. And suppose the x1 to x500 are a sequence and it's IID. And at that n equals the average of the x1 to x500. First, find the expectation of x. First, we see this PDF is symmetric. The PDF Laplace PDF is symmetric about y-axis. So that is the expectation of x equals 0. Now, we know that for part B, if lambda is 10, and use Chebyshev inequality to find the lower bound. What is Chebyshev inequality? It's probability of x minus mu greater than epsilon is less or equal to the variance of the random variable divided by epsilon squared. So I write it down here again. So it's the absolute of x minus mu greater than epsilon less than the variance of x divided by x epsilon squared. So now I want to find the m. So the m will be the probability of m 100, 500 minus the mean. We find the mean will be still 0. Well, the mean, I can write it down, is this. And you'll find it's 0 because in part A, the expectation of x is 0. And if I have an expectation put here and put here, since it's 0, 0, 0, 0, 0, it's still 0. So now greater than epsilon, we choose 0.1 because we have 0.1 here. So it should be less than the variance of m500 divided by epsilon squared. So now we want to find the variance of epsilon, variance of m500. So variance of 500 is variance of x1 plus to x 500 divided by 500. And since they are ID, so it's variance of x1 divided by 500 plus variance x2 divided by 500 plus 2 variance x 500 divided by 500, and this is 500 square variance x. Since I have 500 times, so this times 500, which is 500 only. Variance of x is here. 2 to the lambda, 2 divided by lambda square. So 2 divided by lambda square. So next, actually there'll be the probability of M500 minus 0 greater than 0.1. That's then the variance of x divided by n times 0.1 square. N is 500. Zero point 0.1 and 0.1 square, and then we take the variance is lambda divided by 2 divided by lambda square. Lambda square is 100. So then you have 500. It's 5 here. There'll be 0.004. Therefore, the probability of M500 minus 0 less than 0.1 actually equals 1 minus probability of M500 minus 0 greater than 1. Here's greater than 1. And this is also greater than 1 minus 0.004. Because this probability is less than 0.004. So 1 minus this will definitely greater than 1 minus 0.004. And part C, use the central theorem, the central limit theorem, to find the probability. Okay, so we know if A less than M less than B, the probability of this is actually the Gaussian function. Like B minus mean divided by sigma divided by n absolute square root of n minus the Gaussian A minus mu, the sigma divided by square root of n. And here our mean, our mu is expectation of x, which is 0, and the sigma square is variance of x. So if I want to find this expression 500 M500, actually there will be like B 0.1 minus mu, mu is 0, divided by sigma. Sigma we just found it's the sigma of M. It's here. If lambda equals 10, so it should be 2 divided by 500 times 100. This one. So that's sigma of M. Put the M here. Divide by 500 minus the 5 minus 0.1 divided by sigma n divided by 500 divided by square root of 500. That is the answer.